Let's resume with this slideshow um, and talk about the unit circle. Okay, so the unit circle, as we were discussing in class. So we take a circle, we talk about angles of rotation, all right, the angle measuring alpha. Uh, the angle is a sweep around a circle, a radius 1. The circle, of course, in algebraic terms is x squared plus y squared equals 1. We mark off all the pivotal stops here along the way, which are, of course, the 90-degree stops at on the unit circle where it intersects the x and y axes. Okay. The radius of the circle is 1, and if we draw a triangle from this, come back, sorry. Okay. We're back. We draw the triangle. We designate this point on the unit circle xy. And so this height is y, and this length here is x at any time with this angle rotating. Okay. The sine of the angle, by definition, is opposite over hypotenuse. So that's y over 1, or just y. The cosine is the adjacent over the hypotenuse, which is x over 1, which is just x. So the sine is the y value and the cosine is the x value. All right. So this point no longer is designated as xy, but cosine sine, cosine of angle, sine of alpha. The tangent is the opposite over the adjacent, which is y over x, but since y is sine and x is cosine, this tangent is sine over cosine. Since y equals the sine and x equals the cosine, the unit circle is now named sine squared plus cosine squared equals 1. But then that becomes a Pythagorean identity, which we'll get a lot of mileage out of, okay? We talked about deriving the graphs, all right? Let's talk about the quadrants here, all right? Here's our angle of rotation, alpha. Rotating it at 90 degrees puts us at this point right here, positive y axis. 180-degree sweep is around here. Remember, the direction of rotation counterclockwise is positive, okay? Quadrant 1, then of course we see that the x's are positive, the y are positive, so therefore the cosine and the sine are positive, since sorry about that. Okay. Quadrant 1 contains angles on the intervals from 0 to 90. X is positive, y is positive. So sine and cosine are positive, since cosine is the x value, y is the sine value. So sine and cosine are both positive. Tangent, being the ratio of those two, is also positive. Quadrant 2, any point in quadrant 2 has a x negative and a y positive, so that and any point in quadrant 2 is determined by an angle of rotation of between 90 and 180. And so x is negative, which is implying that the cosine is negative. Y is positive, which is implying that the sine is positive. And the ratio of x over y, which is cosine over sine, would be negative. So only the sine would bear a positive value in quadrant 2. Quadrant 3, of course, both x and y are negative. X being cosine, y being sine, are both negative. The ratio of sine over cosine is the tangent, which would be positive. All right. And of course, any angle in that quadrant is designated as an angle between 180 and 270. And in quadrant 4, we have x being positive, y being negative. All right, so that is implying the cosine is positive, the sine is negative, and the ratio of them, the tangent, is also negative. All right, so we have a little mnemonic. All study trig carefully, and you better believe it. All study trig carefully, meaning working your way around the quadrants. In quadrant 1, all the 3 major trig identities, trig ratios, sine, cosine, and tangent, are all positive. In quadrant 2, S is for sine, which is to imply that only the sine is positive in quadrant 2. In quadrant 3, the tangent is the positive, T for tangent, T for trig. And in quadrant 4, the cosine is positive, and the sine and the tangent are negative. So all study trig carefully. All study trig carefully is a little mnemonic we have for that. Reference angles. By reference angles, we mean basically the smallest angle relative to the x-axis. The smallest angle relative to the x-axis. Okay. So we're looking at 3 angles. We're looking at the 30-degree angle here. Okay, that is on the unit circle. We're looking at the 150-degree angle. We're looking at the 210-degree angle here, and a 330. Now they all have something. They all have something in common. They all have the same reference, and that reference is 30. Because the angle here of 150 is 30 degrees short of 180. Okay, 30 degrees over 180 puts me in the quadrant 2, and 30 degrees short of 360, 30 degrees short of a full revolution puts me in this position here, 330 degrees. Okay, the smallest angle relative to the x-axis, easy to see, is 30 degrees, each one of these. 30 degrees, 30 degrees, 30 degrees, 30 degrees. So if I were wanting a formula, I'd have to have a formula for each quadrant. So in quadrant 2, the formula for the reference angle alpha would be, excuse me, would be 180 minus the angle. So I have 150. What's the reference? 180 180 minus 150. If I'm in quadrant 2, the reference angle formula would be the angle less 180. So it would be 210 minus 180, or 30. And in quadrant 4, the reference angle would be 300, which would be 360 minus 330. Okay, we just remember kind of where it swings to, and the relationship that the reference angle is always, okay, always the smallest angle relative to the x-axis. The smallest angle relative to the x-axis. Okay, what we can say about these is, okay, if you think about this, okay, the height here is 1/2. All right, in other words, a segment connecting D and E would be of 1/2, and that would mean that the y values there would be 1/2. Over here, the height here would be 1/2, but it would be negative. Okay, and so if I were to look for the sine of 30, of course we know it's 1/2. This would say that the sine of 150 is also 1/2. And the way which we can remember that is from the the previous little mnemonic, all study trig carefully, that in place then, okay, in quadrant 2, the sign is also positive, and its numeric value is 180 minus 150, or 30 degrees, okay? Down here, the reference angle is 30, so the numeric value of the sine is going to be 1/2, but it's going to be -1/2, because of our quadrant that we're located in which, again, all studied trig, only the tangent is positive, okay? Lastly, over here in this quadrant 4, we know that the cosine is the only positive, so 1/2 is the value of the sine, but the sine is negative in that quadrant. Okay, so there is what we have. Now, doing that would enable us to fill in this chart. Okay, we'll not worry about the radian values right yet. We'll take that into consideration in one of the next videos. Okay, so the reference angles in quadrant 1 are just the angles themselves. Okay, again, what's the reference angle to 120? Well, okay, these are second quadrant angles, so it's 180 minus this angle is the reference angle, which would be 60, 45, 30. 210 through 240 are in quadrant 3, where the reference angle is this value minus 180. So this is 30, 45, and okay, the 60 degrees, okay? And so we are able to identify the reference angles, our sine, cosine, and tangent values that are in this cluster here, which we should know for 30, 45, and 60, are going to repeat themselves again and again and again and again. The numeric values are going to repeat themselves. The positive and negative nature of those sine, cosines, and tangents are going to fluctuate depending upon the quadrant that we fall into, and as we've seen on the previous slide, as determined by the all study trig carefully indication here. Okay, so that'll do it for this slide. We're going to have you do some exercises pertaining to this and filling this table out and other relative things. Okay, so that's going to do it for this presentation. Alrighty.